Section 3.4, proofs with perpendicular lines. Don't miss distance from a point to a line definition here. A lot of people in the past have missed that one. Don't be one of those people. You're going to want to practice each of these constructions. Definition here, perpendicular bisector. Practice this construction as well. And there's another one here that you want to practice. This one's not in our textbook, but it is one that you're still going to be responsible for. So, and I've made videos for all three of those, so you're going to want to check out those videos on how to do each of those constructions. Alright, example 1 is a proof, and we're going to be proving the perpendicular transversal theorem using this diagram here, and we're going to use alternate interior angles. So let me set up two columns here, statements and reasons. One, to restate the given, which again, you're going to have to rewrite the whole thing. You can't just put squigglies like me. 2, since J is perpendicular to H, so since line J is perpendicular to line H, that makes angle 2, measure of angle 2, 90 degrees. Definition of perpendicular. Statement 3. What do we know about angles 2 and 3? Angle 2 is congruent to angle 3 by the vertical angles theorem, VAT. Statement 4. The fact that line H is parallel to line K, H is parallel to K, tells us something about angles 3 and 6. Angle 3 congruent to angle 6 by the alt int angles theorem, which the directions told us to use, so we just did. Angle 2 is congruent to angle 3, angle 3 is congruent to angle 6, angle 2 is congruent to angle 6, transitive property. So angle 2 is congruent to angle 6, therefore the measure of angle 2 is equal to the measure of angle 6. How do I know that? Definition of congruent angles. I know what the measure of angle 2 is. So the measure of angle 6 equals 90 degrees. Substitution property. Therefore, statement 8, line J is perpendicular to line K, since we just made angle 6 a right angle. Definition of perpendicular lines. Q, E, D. Okay, do the indicated construction clearly enough so that your method can be understood. In other words, we want to be able to see all the arcs and tick marks that are needed in order to do these constructions. So we're going to start off by doing the perpendicular bisector of segment AB. I'm going to switch to a pen here, so hopefully I don't make any mistakes when I do this. Okay, so to do the perpendicular bisector, we need to put our crosshairs or center of rotation on each of the endpoints. I'm going to put on point A first, and then I need to just set my radius to something that is beyond the midpoint. I don't know exactly where the midpoint is yet. I'm actually going to be finding it when I do this. But I want to set it somewhere beyond where the midpoint is approximately. Okay, so I'm going to set it out to here, and I need to draw an arc. A little bit off the page here. I need to draw an arc back onto point A here. Up here. And down here as well. Now keeping that same radius, I can't change the length of the radius, even though the radius length was random. As long as I keep the radius the same length, and I move my center to point B here, and I draw my two arcs. Now when I connect these two arcs, I have just created perpendicular bisector of segment AB. Okay. Now, through the midpoint of segment AB, which is right here, we're going to construct a line parallel to segment AC. So we're going to have a parallel coming through this point parallel to AC. Okay, so to do that, I need to make an arc. Make this one a little bit smaller. Starting at point A. Basically what I need to do is I need to make a copy of this angle at this point here. Okay, so we're going to copy this angle. That's essentially what happens. So I'm going to set an arc here. And I'm going to make a copy of that arc. Same radius that I just made. I need to set my radius, the distance from this arc intersection to this intersection. Hopefully I made it far enough out. So my radius now is set to the length of this arc. Okay. So now I can come up here. And where these intersect, I can draw through this point and this point, and these lines are parallel. So through the midpoint of segment AB, construct a line parallel to AC. Done. Does line M, so let's call this one must be, this is line M here. Does line M appear to contain the midpoint of BC? It definitely looks like it. It does, and we can prove that later on, but for now, it appears to contain that midpoint, and that's important to us in the future. Okay, so that's example 2. Example 3. Do the indicated construction again. The perpendicular to segment BA at point A. So we're going to do something perpendicular to this segment going through this point. To do that, I first need to extend BA. Let's extend it a little bit longer. That should be long enough. And I'm going to make a radius pretty much any length. My radius is going to be here at point A. The center is going to be here at point A. And I need to mark 2 points. 1, 2. That A is the midpoint between these 2 points. That's what I need to mark, which I just did. What essentially we're doing now is we're kind of working backwards. This is a segment. This is the midpoint. Now I'm going to draw a perpendicular through that midpoint using the technique that we use to make a perpendicular bisector. And again, to do that, I need to set my radius longer than the midpoint. Switch it up. And I don't need to do the arcs up here as well, because I don't need to connect the 2 arcs. I just need to connect these arcs to point A, because I already have my point A to use. And there is my perpendicular to BA through point A. Okay. Example 4. We're going to draw a parallel through ED, parallel to ED through point F. Okay, so again, we essentially need to connect from D to F. I could do it, you know what? On the answer key, I connected from D to F and I copied this angle. I've already got E to F connected. I'm going to try copying this angle over to here so that you can see it different than on the answer key. Hopefully this fits and it works. Oh, let's make an arc. Make it a little bit bigger. An arc that hits ED and EF. Copy this same arc. And I need to extend EF a little bit more so that it's going to hit. Now I need to measure and set my radius to the length from this intersection to this intersection. Come over here, keep that same radius. Make my arc. And now draw from F through that intersection. And these lines are now parallel. Okay. We're going to construct a 45-degree angle, a 135-degree angle, a 22.5-degree angle, and then this is the tricky one, a 105-degree angle. 45 is not hard. 135 will be done when I've done the 45, and the 22.5 is also not hard. This one's the only one that's a little bit tricky. Okay, so I'm going to do these on the back side. I have more room to do that. And let's see here. To do the 45, I'm going to first construct a 90. So And to construct the 90, I'm going to do the perpendicular bisector of this segment. Set my radius. Draw my two arcs. 1, 2. Put it around, keeping the same radius. For my third and fourth arc. Connect them. And we have a right angle. But we didn't want a right angle, we wanted a 45-degree angle. That's okay, because half of 90 is 45. So all I need to do now is cut this angle in half. So we're going to bisect this angle. I'm going to set my radius to some random radius that's long enough so then when I measure between the two arcs, that's big enough to reach. Alright, as long as I'm beyond the midpoint here, the bisector point, that's enough. There, arc. Arc. Bisector. This is 45 degrees. Now, I could go through this whole process again if I want to make a 135-degree angle, but I'm not going to because this is 135 degrees. 90 plus 45 is 135. So that's a quick way to get the 45 and the 135. 22.5 may seem random, but it's just half of 45. So I just need to bisect this one. You can do that pretty quickly. Arc. Arc. Connect. And suddenly we have a 22.5 degree angle. So there's 45, 135, and 22.5, which is parts A, B, and C. Now, I'm going to do a new one to do part D, which is 105 degrees. And this one's a little bit tricky. So again, I need to start off by making a 90-degree angle. Around. Here's my 90-degree angle. I now need to cut that in half to make a 45-degree angle. My goal is to get 105 degrees. So this is 45 degrees here. I still want 105 degrees, but 45 plus 60 is 105. So now if I can make a 160 degree angle off of here, from this line, if I can make a 60 degree angle up, then I will have 105 degrees from the 45, from the 45 plus the 60 will give me 105 degrees. Or I could do 45 plus 60 here. Let's do that one. So I'm going to do it from this angle here, actually. So from here, I'm going to make a 60 degree angle. Might be a little bit easier to see. I may need to grab another color and highlight when I'm done. So how do we make a 60 degree? Well, we actually did that probably about a month ago by making an equilateral triangle. So I'm going to set my radius to some marks that I've already got. So I've already got this marks, and I'm going to use that as my radius. Come out here, put an arc, flip it around. It's on paper, yep. Make an arc. That means from here to here to here to here, all three of these are the same length, which makes that an equilateral triangle, which makes this $60 degrees from here to here. I'm just going to mark this one as 30 so that we know. And that means that from here to here is 105 degrees. And let me see if I've got it. So here I have a blue pen that will highlight this final angle. I didn't have a highlighter. Highlighter would have been better. I do have a different color, so it'll stand out a little bit more. And right here is the 105 degrees. And that is section 3.4. Thank you.